So this video is a continuation of the start of the discussion of light and why we're going to use it to detect essentially where the electron is located. So again, electromagnetic spectrum, but what we're going to now focus on is some calculations associated with this. So there's going to be two major calculations we're going to do. So the first one is we have a relationship between the speed of light and its wavelength and frequency. Again, going back to your book, section 5.1 goes over these two. This is called lambda, and this is called nu. Okay, so we have wavelength is a lambda and frequency is a nu. Sometimes you will see books refer to frequency as a letter F, but most chemistry textbooks uses this weird looking V, a nu, in their discussion of light calculations. So we know that the speed of light is always a constant. It is 3 × 10⁸ meters per second. It's actually 2.998 something, blah, blah, blah. And a few years ago, they thought that they found something that was traveling faster than the speed of light. It turns out it was just a calculation error. So we still, at this point, do not have anything that goes any faster than the speed of light. So that is meters per second. So since that is meters per second, your nu is going to be the inverse of seconds, or something called a hertz. A capital H and then a lowercase z is sometimes how you abbreviate a hertz. Seconds could be 1/s. Sometimes you see s -1. That's going to be the unit of frequency. And then wavelength is going to be in meters for this calculation. So when you multiply these two, you get meters over seconds. So wavelength and frequency have what we call an inverse relationship. So as you increase the wavelength, so going back to the electromagnetic spectrum, as I increase the wavelength, you're going to see that frequency gets smaller. So this is an inverse relationship. But what you're going to be doing is just some calculations. So speed of light is always going to be the speed of light. And what you're going to be asked to do is to find the frequency if you're given the wavelength. So you're always taking the speed of light and dividing it by the other variable. If I'm trying to find wavelength, I'm going to take the speed of light and divide it by the frequency. So the good news is it's always 3 × 10⁸, and you're dividing it by whatever you were given in the problem. So I'm going to show you two examples of this so that you have something to kind of refer to, but it is the same calculation over and over and over again. You're just going to see a difference in terms of the numbers. So what is the frequency of light if the wavelength is 4 × 10⁻6 meters? And the thing you do need to pay attention to is significant figures. So if I'm starting with 4.0, that is 2 significant figures. So that means I need to have 2 significant figures in my final answer. The power of 10 does not determine the significant figures. So pause the video right now and see if you can come up with the frequency of light, and also be aware that you're going to be asked the units. So you're going to have to keep the units straight. So again, pause the video and then see what answer you get. All right, so if I'm trying to find frequency, that's going to be the speed of light over wavelength. So I'm going to take 3 × 10⁸ over 4 × 10⁻6. The meters will cancel out and I'll be left with 1/seconds, or you could call it a hertz, or s to the -1. Again, you need to be aware of the calculator and how to put this in your calculator. So this is where you're going to use the double E function in your calculator again. That's going to be, again, it's probably a second function on your calculator, so find the EE. So you're going to type in 3 second function, E, so that it comes on the screen, 8 divided by 4 second function E, -6, and then press enter. And it will give you 7.5 × 10⁻13. So that double E function on your calculator is going to be very valuable because you're going to be always dividing, and dividing does sometimes, it doesn't work on your calculator unless you put things in parentheses, which you can do, but it's much easier to use that E function, much easier to use that E function. So again, that's finding frequency. Well, what if you're trying to find the wavelength? Okay, what is the wavelength of light if the frequency is 2.6 times 10 to the 15th 1/seconds? Or I could have called this a hertz, it does not matter. So again, just like before, pause the video and see if you could get an answer. And then when you come back from the video, or from the pausing of the video, see if you got the right answer, including units. All right, so again, same as before. I'm always taking 3 times 10 to the 8th and dividing it by 2.6 times 10 to the 15th. So it doesn't matter if I'm finding wavelength or I'm finding frequency, I have exactly the same type of calculation. All right, so again, show it to you on your calculator here. All right, 3 second function E, 8, and you hit division. And this is 2.6 second function E. So you get the E in the screen, 15, and you hit enter. Okay, now again, if your calculator gives it to you in normal notation, what you could easily do is convert that. So if I hit the second function here, it's going to say scientific. If I toggle over there and I hit enter, it will change it to the power of 10 that I'm looking at. So 1.2 times 10 to the negative 7th. Again, I only can have 2 significant digits because I only have 2 here in the beginning of the problem. So again, that is how you do light calculations with the speed of light,